Hello. So tonight we'll be looking at question 5 from November 2017 final exam. So we're still looking at functions for paper 1. So the given information for question 5 says that the diagram below shows the graphs of g of x, which is equal to 2 over x plus p plus q, and f of x, which is equal to log base 3x, right? So this is our hyperbola, right? Hyperbola or hyperbolic function, and this is our exponential. We have already looked at this one. I've explained what exponential functions are. So okay, so let's just look at hyperbolas. Let me just scroll down here, and I'll just try to explain hyperbolas in less than 3 minutes. So if you understand hyperbolas, you can skip this section. So hyperbolas, they're usually given with and using this general formula, which is a over x plus p plus q, right? And then when you draw them, let's say this is y axis and this is your x-axis. You will draw them like this. So this is the general hyperbolic function, right? And then you will have, let's say this is your f of x, and then you will have something like this. I will explain what that is, and then you will have something like this, right? So this will be x. Actually, this is minus x, right? And this is your y is equal to positive x. So let's explain what each and every one of these values mean. So if you have a, so a could be plus or negative. If you have a plus a, then your function looks like this. So this is a positive a. If you have a negative a, then your function looks like this, right? If you have a positive a, this is called an increasing function, right? So this is an increasing function. If you have a negative a, we call this a decreasing function, right? Increasing function means that you have a positive gradient. This means you have a negative gradient, right? You can tell on that side, and this is in that direction, right? And then what does p mean? So your p, where you have x plus p here, when you equate this to 0, you get x is equal to minus p. This minus p is your what? Your vertical asymptote. So when you're asked to determine the vertical asymptote, you say x is equal to minus p, right? So if this is given, then you can find x plus p by just taking this negative to that side, so it becomes a positive, right? So you just change its sign. Then q, this plus q, this is your horizontal asymptote, right? So this is y is equal to q, this is your horizontal asymptote, right? So what are asymptotes? Okay, we've been talking about asymptotes. What are they? So asymptotes, these are lines where your graph will approach but never cross. So for example, our graph does not cross the x-axis and the y-axis. So it means that these are what are asymptotes. So this will be your horizontal one and this will be your vertical one, right? It's a vertical line. So because this is for a general equation, right, where p and q are both 0, so that will be y is equal to a over x, right? So this was something, these two lines here, these are not part of the function, but rather these are axes of symmetry. So axis of symmetry, this is a line that reflects, if you reflect the graph about that line, you get what? You get an inverse of that function, right? So it's kind of like a mirror between your, that divides your graph into two, right? Or your function into two. So that's called your axis of symmetry, right? So for hyperbolas, what is your axis of symmetry? If the function, the equation is just a over x, p and q are 0, you have this as your axis of symmetry. It's a different story when your function is y is equal to a over x plus q plus p plus q, right? Your axis of symmetry here, the one with the positive gradient will be x minus p plus q, right? And then the other one with a negative gradient will be x negative into negative p q, right? And so these are what your axis of symmetry. Let's just, because there's two of them, so let's just say axis of symmetry. So that's a quick rundown on what each and every value here actually represent. You see P, Q, A, and also what are axes of symmetry, because they are very, very important. You might find them in this equation. Actually, we have them in this equation, right? So I won't remove this. We'll refer back to this one if we need anything from here, right? So let's just get started with our business of the night. So we have 5.1, right? Equation actually. So it says that we have these equations, right? Now we know what P means. So P is your horizontal asymptote, which is x is equal to minus P, vertical asymptote, I mean, and then this is your horizontal asymptote. This is positive, so your graph looks something like this, right? It's in the first quadrant and the third quadrant, okay? So this is your exponential. We have already talked about that one, so we won't get to that. We'll get to that at a later stage. So yeah, but something that you might realize is that now we have a log, right? You usually see this when you find the inverse, right? So you, to understand these ones, you would really need a brief understanding of what a brief understanding of logarithm laws, right? And what log means, what does it actually represent when it's a function, right? For example, this is y is equal to log base 3x. What does this actually mean? How can you get rid of the log? You can get rid of the log by writing this as y is equal to 3 to the power y. I'll explain how to do that at a later stage, right? So let's just get to our given information. It says y is equal to minus 1 is the horizontal asymptote of g. So you can already tell that our q is minus 1, right? Because that's our horizontal asymptote. And then b, which is 1 and 0, is the x-intercept of f. F is a different function. It's the exponential, right? It's the x-intercept, okay? Let's take note of that. It says that a, which is t, and 1 is a point of intersection between f and g, right? So it's talking about this point here. It lies on g and f, so we can use either equation to find the value of t. And then you also have this b here, which is the x-intercept of f. And then they say the vertical asymptote of g, which is x is equal to minus p, intersects the x-axis at E and the horizontal asymptote at D. Okay, so this is your E. So this is our vertical asymptote because it intersects these 2 points, right? So this is your vertical asymptote, which is x is equal to what? To the value at E, okay, and also at D. So let's see. They say that OB is equal to BE. What does this mean? There's two distances. Let's look at that. From O to B, this is 1. So this is 1 unit. From B to E, if these two are equal, then it means that you also have 1 unit. So here you will have 1 plus 1, that's 2 and 0, right? And here it will be 2. And then this lies on y is equal to minus 1, so this will be minus 1. Therefore, this is x is equal to what? 2. So this is your negative p, right? Your vertical asymptote. So they say write down the range of g, right? So the range of a function, this involves what? All the y values of the function, right? Where the function is defined, right? So it means that this is where the function crosses all the y values, and but this will not include the asymptotes, which is the horizontal asymptote. Because for example, g goes like this, right? And then it goes like that, and then you also have it in that direction, right? So but it does not cross this line, which is y is equal to minus 1, right? So it just goes like that, like that. So it means that the function is not defined at -1. So to write the range, so it defined everywhere but at -1. So to write that range, how can you write it in a mathematical way? You write it as so let's just say range is a y is an element of all real numbers, but y is not equal to -1. Or the way you can write it, you can just write y is an element of -1 minus infinity, or y is an element of let's see, -1 positive infinity, right? It starts from -1 up to negative infinity. It starts from -1 up to positive infinity. So this is the other part that's like this. This is the part that like this, right? So that's so you can write it as like this. Just do that. You can write it as this or in this fashion. This is simpler, so I would recommend just use that one, right? But it's better to diversify your methods so that you can always confirm with the other one. So 5.2 says determine the equation of g. Okay, so we're given that g of x is equal to 2 over x plus p plus q. We've already determined that, so our vertical asymptote is equal to x is equal to 2. I've said that this is equal to minus p, right? And then your horizontal asymptote is equal to y is equal to -1, right? Which is equal to q. Therefore, g of x is equal to, so this minus p means that this p is equal to -2, right? So you have 2x minus 2 minus 1. So that's your function of, that's your equation of g, right? It's 2 over x minus 2 minus 1. So that's your function, that's your answer. And then let's just look at 5.3. So 5.3 says calculate the value of t, right? So t is, this is your x value of a, and we say that t lies on what? On g and also on f. We have the equation of g, so we can just substitute a to g and find the value of t, right? Because that will be x is equal to t, y is equal to 1. So let's just do this. Sub a, which is t, and to g of x. So we're gonna have something like 1 because this is the y value, and then we'll have t because this is your x value at 1, minus 2 minus 1. You take this that side, it becomes positive, so you have 2 over, and then you have 2 over t minus 2. You cross multiply, you have 2 multiplied by t minus 2, which is 2t minus 4, because that's 2 multiplied by minus 2, and then 2 by 1 is 2, right? And then you have 2t is equal to, this becomes positive, that's 2 plus 4, which is what? 6. You divide by 2, therefore t is equal to 3, right? So we've found that t is equal to 3. Okay, so we can move to question 5.4. So they ask us to write the equation of f to the power -1, which is the inverse of f, in the form of y, right? So I said that, so let me just do a general equation of a logarithm of log. Let's say we have log base a x. So what does each and everything mean? It's important to always ask, what does this mean? What does that mean? Right? Everything here. This is the base, and this is the exponent, and this is the answer. So this can be written as what? Your base your exponent, and then your answer. So this is a to the power y is equal to x. That's your answer, right? So since we're given that f of x is equal to log 3x, you know this is y, right? And this is your base, this is your answer. So therefore you can have what? You can start with the answer, and then you have 3 to the power y. When you want to find the inverse, you what? You interchange, right? So you interchange, x becomes y and y becomes x, right? So you will have what? Therefore f minus 1 to the power x is equal to 3 to the power x, right? So y is equal to 3 to the power x, and then you're done, right? That's simple. So 5.5 asked us to determine the values of x where f to the power minus 1x will be less than 3, which is your inverse. We just found that. So that's what? That's 5.5. Yes, 5.5. So that's 5.5. So we have got this inverse less than 3. So we can just write our equation. This 3 to the power what? 1. Same base, equate the exponents. Therefore, this is x is less than 1. That's your answer. And then we'll look at 5.6, right? It says determine the point of intersection of graphs f and the axis of symmetry of G that has a negative gradient. Okay, so we want to find what? The axis of symmetry, right? So we can go ahead and draw the axis of symmetry, just like a rough representation of how we think they look, right? So this is the one with the positive gradient, right? And this one will be the one with the negative gradient. I don't know if it cuts at B. It seems like that, but we cannot assume that, right? So what are the equations of these two lines? I said that if it's the increasing one with a positive gradient, it will look like this, minus P plus Q, right? You substitute what? Minus P, which is what? Which is this will be x into what? X minus minus 2. This will give you what? X is equal to x minus 3, 2 and what? 2 and minus minus 1 that side. So this will give you what? Y is equal to x minus 3, which makes sense because this is minus 1. We expect minus 2 to be around there, and then minus 3 around here, or around here, right? And this one will look something like minus x minus p plus q. This is minus 2, this is minus 1. Therefore, this will look like minus x plus 1, because minus into minus 1 will be what? Plus 2. This is q is minus 1, right? So it looks something like this, right? So that's our axis of symmetry. So this is what I said here. This is our axis of symmetry for positive, and this is for negative gradient. So we can write the axis of symmetry. Axis of symmetry, the one with the positive gradient, because we have two of them, right? So we want the one with the positive gradient, which is y is equal to minus x plus 1. So we want to find the intersection between these axes of symmetry and the function of f, right? So let's just look at what we drew on this graph. We drew A to cut B, but we're not sure. So to make things easier for us, we're just going to check if B is on the axis of symmetry, right? If it's on the axis of symmetry, then it's our point of intersection. If it's not, then we'll have to do it the long way, where we equate these two functions, right? F of x and the axis of symmetry. So let's just check. So we check B, because I said we don't assume, right? So we check B, which is 1 and 0. We can check this by substituting any of this, either of these values into that. We substitute 1, right? So we'll have minus 1, because that's x, plus 1 gives us 0, which is the y value of B. Therefore, B lies on the axis of symmetry. And then we can conclude that intersection point is what? 1 and 0, right? So yeah, this is what we have. So that's all for tonight. So let's just do a recap on what we did, right? So we looked at hyperbolic functions. So I gave you a rundown on what each and everything means actually, and how to make life easier for ourselves, right? So we found this, right? This one, x. So we found that this one, x, actually I've also written is x is equal to minus p. This will be a 2, so minus p is equal to 2, which is your vertical asymptote. Q is equal to minus 1, which is your horizontal asymptote, right? And your A, if it's positive, you have an increase in function, which is in the first quadrant and the third quadrant. Negative, you have a decrease in function, right? So you can always expect, so this will help you when you ask to draw the function, right? So if you have A, you do expect your function to be in the first and the third quadrant. If it's not there, then you know that something is wrong, right? Something is wrong. And then we also looked at the axis of symmetry. You have 2 for your hyperbolic function, right? You also given what? I also gave you these 2 formulas, right? They've been proven to work for axis of symmetry. So this is for when you have a positive gradient, which is a line that goes in the direction, right? It's increasing. So as the y values increase, the x values are also increasing. So the one that goes in this direction, which is the negative one, as the y values increase, the x values are decreasing. So this is a decreasing graph, a gradient or negative gradient, and this is a positive gradient, right? So, or an increasing gradient, right? So this you are given 2 different formulas for that, which is actually just a negative that makes it different. So that's what you have. And then we answered the range. I said rather use this one, because range is all sort of y values where the function is defined, right? Which does not include asymptotes. We found this equation very fast, because we knew what p meant, we knew what q meant. So this 2 is minus p. So since you have positive p, you can just take this negative to this side. So you have negative 2 there, you have negative 1 there, because y is equal to q, which is negative 1. That's your function. We wanted to find the value of t, which is the x coordinate of a. We know that a is an point of intersection between f and g, so it also lies on g. We know what g is, substitute, we get t. We found the inverse of f, which was very quick, because we understand what logarithm mean, and actually what are the laws of logarithm, right? So we know that when to find the inverse, you just interchange. So we found y is equal to 3 to the power x. We're given this, we need to find the values of x. Simple. X less than 1. Axis of symmetry, wanted to find the intersection with f. We avoided the long way of having to equate the 2 functions, which you can do that if you have time, right? But it's better to simplify things. So we just realized that this axis of symmetry could actually be passing through 1, right? You can also check if that is true, right? You can also check by using the gradient. what is the gradient of b and d? So this is your y2 minus y1 over x2 minus x1 minus 1 minus 0 and 2 minus 1. This is minus 1 over 1 bd is equal to minus 1. Which one also has a gradient of minus 1? The axis of symmetry. So B lies on BD. BD is the axis of symmetry. So you can also use the gradient, right? So that's how simple it is actually. So mathematics, they say there are many ways to skin a cat, right? Don't skin cats. Just kidding. But there's many ways to skin a cat, right? So it means that you can solve a problem using different formulas or different methods. If you know a different methods to what I've used, or you want to try other methods to the ones I've mentioned, you can try those ones, right? To try to see if you get to the same answer. For example, here, equate f of x with y, right? The axis of symmetry, and try to see if you get to the point 1 and 0 as your point of intersection, right? So yeah, that's all for today. That's all for tonight actually. If you have questions, suggestions, or something, feedback, just drop a comment and I will attend to it as soon as I can. Thank you.